Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we will be discussing about scope rules. So the scope of an identifier is the portion of the program in which the identifier can be referenced. For example, I have this program and this program has different portions. Here we have the portion which is outside of the main throughout the program. Also we have the portion which is inside of the main function, and also we have the portion where we have another function inside main. So in fact, a nested function inside another function, and the portion that we have in here. So the scope of an identifier is the portion of the program in which the identifier can be referenced. Some identifiers can be referenced only inside the function. Some identifiers can be referenced outside of the function that it was defined, and some identifiers can be referenced throughout a program. The four identifier scopes that we have are function scope, file scope, block scope, and function prototype. Stay tuned as we will be discussing about each one of these identifier scopes in the coming episode. Hello and welcome to this episode, and if you remember that we discussed a different type of scopes in the previous episode. In this episode we will be covering the function scope. So in function scope, labels are the only identifiers with a function scope. Labels are identifiers that are followed by a colon. For example, if you remember the switch statements, we had the cases, and these cases are called labels, and these labels, they have the scope of a function scope. That means that labels can only be used anywhere in the function in which they appear, but they cannot be referenced outside of the function body. And labels are hidden in the function in which they are defined. This principle of hiding information is a mean of implementing the principle of least privilege, which is a fundamental principle of good software engineering. In the context of an application, the principle states that code should be granted only the amount of privilege and access that it needs to accomplish its designated task, but no more than that. And that's why we have labels. As we said before, the scope of a label is function scope. And once again, function scope means that labels can be used anywhere in the function in which they appear, but they cannot be referenced outside of the function body. Stay tuned as we go into more scope rules in the coming episodes. Hello and welcome to this episode, and in this episode we discuss the file scope. An identifier that is declared outside of any function, it has a file scope. It doesn't matter if that identifier is a global variable, it is a prototype, or if it's a function definition. All of these three identifiers, they have a file scope, and that means that such an identifier is accessible to all of the functions from the point at which the identifier is declared until the end of this program or the end of this file. So for example, this global variable is accessible inside of this function, and also this function. And for example, this function definition, which is defined outside of another function definition, that means that this function is accessible here in main and also in the function 2 as well. And that's what a file scope is for an identifier. Stay tuned as we go into more scope rules in the coming episodes. Hello and welcome to this episode, and in this episode we will be discussing about block scope. So identifiers that are defined inside a block, they have a block scope. For example, here in one of our functions, we have this local variable. This local variable number, it has a block scope. And also the parameters that are defined here in the parameter list of the function, they are also the local variables, and they also have a block scope. A block scope ends with this termination of the function. So that means that this variable is not accessible anywhere out of this function, out of this enclosure. And it's the same for this second variable, which is called number as well. This number, which has the name exactly with this variable number, but in fact it is a different variable and it has a different block scope. So this number is only available within this function toBlock. Once this function toBlock is executed and finished, this variable is not available anymore. And that's why we can have variables that have the same name, but they are located in different block scopes. Although it's not a good exercise to do that, and it's always a better idea to give this second variable a different name. Also, you need to remember that static type identifiers, they also have a block scope. That means this variable integer is not accessible anywhere out of this function. But still, the scope of this variable is different than the storage duration. Static is a storage duration. That means that how long this variable is going to be stored in the memory. But scope means that where we can access this variable, and that is within the enclosure of this block. Stay tuned as we go into more different types of scopes in the coming episodes. Hello and welcome to this episode, and in this episode we will be discussing about function prototype scope. So the only identifiers with function prototype scope are those that are used in the parameter list of a function prototype, such as these identifiers such as x, y, or z. This is a prototype for the function, which the name of the function is function. Okay. In the parameter list, these identifiers, they have a name such as x and y or z. But in fact, these names or these identifiers are not required. So in fact, this prototype is also correct without having any identifier and only the type of the identifier. So this is also correct. Both are correct. Let me write it here. And that's why the scope of these identifiers that are used in the parameter list of a prototype, it's only in here and that's it. So you can reuse them in anywhere else in the program, such as inside of the function itself or anywhere else in the program. You can reuse these variables and variable names again. And that's it about function prototype scope. I hope this has been informative for you, and if you have any questions, please let me know in the comment section below, and I will see you in the next episodes. Stay tuned. Hello and welcome to this episode, and in this episode we will be discussing about local variables versus global variables. So in here I have written a program. Let me go and run this program, and then I will be able to explain the program for you. Now in here you can see that the value of x inside main is equal to 1. As you can see, inside of the main function we have defined this variable x and we have given it a value of 1. And when we tried to print this x variable, the value was 1. But now we have used the useLocal function. Here in the useLocal function, we have another variable which is called x, and this x is going to be the local variable for this function. And that's why the x variable, which is inside of the main, that will not be used. Instead, the local variable to this function is going to be used. And that's why when we have tried to print the value of x inside of the useLocal function, the value is 10 instead of 1. It did not use the x variable from the main function, rather it used the x variable that was defined inside the block of this function, which is 10. Now again we have used another function which is called useGlobal. This function is using this global variable x, which is defined as 100. Now in here, as you can see that we don't have an initialization and declaration of x inside of the use global function. And that's why the use global function, instead of using its own local variable, which it does not exist, it uses the global variable x, which is available for the whole program, because global variables, they are available throughout the program to all of the functions. The only time that it's not available is that when you have a declaration of the same variable inside of your function. If you don't have the declaration of the variable as a local variable in your function, then the global variable x is going to be used. Now, as you can see that the value of x inside of the use global function, it's 100. It did not use this value of local variables inside of main. It did not use the local variable inside of the use local function, which is local to itself. It rather used the global variable. And that's the difference between the local variables and the global variables. I hope you've got a good understanding of local and global variables, and I want to see you in the coming episodes. Stay tuned. Hello and welcome to this episode. In this episode, I'm going to explain for you the difference between local variable and static local variable. So let's get started. As you can see in here, I have defined these two functions, use local and use static local. One of the functions is going to be using x as a local variable, and the other function is going to be using x as a static local variable. Now I have called these two functions here in the main function. The use local function is called twice, and also the use static local function is also called twice. Let's go and run the program and see the output. Now as you can see here, this is the output of the use local function, the first invocation. Here we have defined x as 10. As you can see, x was 10 and we printed the value of x. Now we added 1 to x and the value of x became 11. And the second time when we called this function once again, the value became 10 once again, even though it was 11. Now in the second call it became 10 once again, because this is a local variable and the value is created and destroyed each time the function is called. Now the difference is that in static local we have the value of x as 20. In the first call of this function, the value of x is 20. It becomes 21 after we add 1 to it. Now in the second call of this function, as you can see, the value of 21 was still retained and saved in memory, and it was not destroyed by the end of the function. Even though the execution of the function completed, the variable was still in memory, and the second time when we called the function, it used that variable. It was 21 and it added 1 to it, and now it became 22. And that's the difference between a local variable and a static local variable. The local variable is going to be created and destroyed each time when the function is called, but the static local variable is going to be created for the first time and is going to be retained throughout the whole program. And if the function is called once again, that value is going to be retained and will be used in the second and third and fourth calls of the function. Thank you for being with me in this episode. I hope this has been informative for you, and I would like to see you in the coming episodes.